Now that we've discovered that CPR and sanitation taken together have the highest R-square with 0.768, we're going to use those two variables as the first included variables and select the third variable that accounts for the greatest proportion of the R-square with CPR and sanitation included. The process for doing that will be similar to the one we just used to discover which were the two best predictors of under 5 mortality. We're going to copy CPR and paste it in AP1. Then we're going to copy sanitation and paste it in AQ1, and now in AR1 we will paste safe water. Now we have the first three variables that will be examined simultaneously. We'll go to Tools, Data Analysis, Regression. The dependent variable is still under 5 mortality, as can be seen here. The independent variable set now will be the new variables that we have selected: CPR, sanitation, and safe water, and this is Control-Shift down arrow. And the output range will now change to AT1. When I say OK, I get the first three variable analysis. And as can be seen here, CPR, sanitation, and safe water taken together account for about 77% of the variance. Now, in the next step, we will insert a column at safe water, and now include the variable health services. So we will copy the health services column and paste it here. Now when we go to Tools, Data Analysis, and Regression, we still have the correct dependent variable under 5 mortality. The independent variable set will still be CPR, sanitation, and health services, as AP1 to AR76 shows. So the only thing that needs to be changed is the output range. The output range will now be this cell, which is AU22. When I say OK, the output now shows that with CPR and sanitation and health services, we're accounting for 78% of the variance. Using safe water, we only accounted for about 77%. So the three variables, CPR, sanitation, and health services, are a better predictor set. We'll continue this process by inserting a column here, adding the next variable, doing the regression, and so on until we've looked at all of the variables taken with CPR and sanitation together. After we have looked at each of the other independent variables with CPR and sanitation, we have safe water with about 77% of the variance, health services about 78%. DPT, again about 78%. Log GNP, not quite 78%. Female literacy, a little more than 78%. And total fertility rate, almost 79%. So it is total fertility rate which, along with CPR and sanitation, accounts for the largest proportion of the variance in the dependent variable. This means that we will use CPR, sanitation, and TFR, total fertility rate, as the included variables for the next step of the analysis. However, one thing has happened which does happen in forward inclusion multiple regression, and that is that now that total fertility rate has entered into the regression equation, CPR with a p-value of 0.06 is no longer a statistically significant predictor. This is almost certainly because of the high correlation between CPR and total fertility rate. Because of that, we're going to drop CPR now from the analysis and retain only sanitation and total fertility rate. An alternative approach would have been to say, now that CPR is no longer statistically significant, let's look at the best three-variable predictor with CPR as statistically significant. And in that case, perhaps we would have chosen the model with CPR, sanitation, and DPT, which accounts for 0.783 or 78.3% of the variance. There is no particular rule that would lead us in one direction or another, but in this case we're going to continue with the example in which we eliminate CPR.